Something you guys might not know is that sometimes I do these videos like 4 or 5 times, and sometimes my battery dies on my phone because I suck at recharging it. Sometimes my memory runs out. Sometimes I just say something really stupid that would be too hard to edit out. And I'll just be honest, this is the 5th time that I've done this problem, and I'm exhausted. But we're going to get through this together, okay? In the last video, I promised that I would show you how to deal with conservation of momentum problems when things break off in several different directions, right? It's not just in X and it's not just in Y anymore, but things will either break off or collide and move in different directions, okay? And how do we deal with conservation of momentum when momentum is a vector, not a scalar like energy? And the answer is you just do what we've been doing with vectors. You isolate the dimensions, okay? So you say now that there's 2 conservation of momentum problems. There is the conservation of momentum in the X dimension, right? Momentum must be conserved in X, and momentum must also be conserved in Y. All right? And so to kind of explore this problem, we're going to look at a situation where we have just a very trivial, silly situation of a plate, right, that drops, okay? And so there's no momentum in X or Y, right? But then it explodes, and now there is momentum in X or Y. You have these 2 pieces that go off in this direction, and this piece here, M3, that goes down in this direction, all right? And the M2 piece goes at an angle of 45 degrees at 1.7 meters per second. And M1 goes off at 25 degrees with respect to Y at 3 meters per second. And the first thing that I notice is this angle here is with respect to Y, and this is with respect to X. So it might make our lives a little bit easier if we actually make these both with respect to X. Okay, so that's got to be 65. That's a 65-degree angle. I think my math is right there. Okay. And then we know the mass of this guy is 1.3 kilograms. The whole goal is to find the mass of M1 and M2. So basically, this is like one of those like forensic crime scene ballistics problems, right? Except instead of with a bullet ricocheting off stuff and trying to find the caliber of the bullet, you're talking about a plate. Not quite as cool, but you know, it's physics. So here's the deal. What is the momentum before in the X direction? Well, it's just a plate that's sitting there, right? So the momentum before must just be 0, right? And what is the momentum after? Well, we have the X component of M2. So I'm going to call that P2X, right? And then, because remember, if this is here, if the velocity is here, then this is the direction of the momentum vector. Direction of momentum vector is always in the direction of velocity, right? In the direction of the motion. And so there's going to be a px component and then a py component. The same thing here. If this is the direction of p, there's going to be a py and a px. But this is going to be 2, and this is going to be 1. And this is going to be 2, and this is going to be 1. Okay, so p2x, right? And then this is in the negative x direction, so that's going to be negative p1x. Okay? So I have p2x equals p1x. Right? Does that make sense? Or vice versa. I think it might be a little bit easier since 1 is on this side and 2 is on this side. I'm just going to switch the order. Right? Basically, I just added this over to the other side. Okay. Now, what is P1x? Well, it's going to be the mass of 1 times the velocity of 1 times cosine of the angle, right? And so this is going to be the mass of the second guy times the velocity of the second guy times the cosine of that angle, right? This cosine that's what we do to find the component of a vector, right? We take the cosine of the angle that it touches, okay? So M1, we know, has, well, that's what we're trying to find, so we'll just say M1. V1 is 3, right? And cosine of the angle that we make with respect to x is 65, so that's cosine of 65. All right? Now we have M2. We don't know what it is. We're trying to find it, right? We know that V is 1.79, and we know that cosine is of 45, right? So if I multiply these guys, I get approximately the same answer for both. It's about 1.27 m1 equals 1.27 m2. Cancel, cancel, m1 equals m2. All right, so this makes our life a lot easier. We don't know what m1 and m2 are, but we have, this is just one equation. We have a whole other equation to deal with, and now we can make that substitution into there to make the problem a little bit easier. Okay, the first thing I'm going to do is actually erase this a little bit so that I can make room for this calculation. Now, one really quick thing, why didn't I include m3 here? Okay, I think you know the answer, and the answer is because m3 is only in the y dimension. Nothing is happening in x for m3. Okay, so now let's start over here. What is the momentum in the y dimension for the plate before it breaks? 0, right? There's no motion of these pieces in y or in x. Okay, so what else do we have to deal with here? Well, we have two positive py's, right? That's going to be the py1, right? And that's going to be py1 plus py2 minus py3, right? That's the momentum of this third piece here going down. All right. So let's start substituting our values in. Py1, well, that's going to be the mass of 1, which we're still trying to find out, m1, times v, again, that's 3, right, times, this time, sine of 65. And now we want to add to that our m2, right? That's this guy, which we still don't know. We're trying to find it. But his velocity is 1.79. Okay. And that's going to be sine of 45. Right? And then we're subtracting py3, which there's no angles here. It's just going to be this 1.3 times 3.07. Okay? Now, from this dimension over here, we know that m1 is equal to m2. Okay? So I can just put in m1 over here. And basically the problem's done, right? With just a little bit of 6th grade algebra, we can multiply 3 times sine of 65, 1.79 times sine of 45, multiply these together, combine these like terms, right? And we find out that m1 is simply around 1 kilogram. Okay, it's going to be the piece of that plate. And that's going to be approximately the same mass as m2 as well. Okay, so go ahead, do the same calculation, make sure I got the calculation right, let me know if I don't. If you have questions, obviously reach out, but oh my God, I think I finally finished this problem. Now I'm going to go walk over to my camera and hopefully it's still recording. You guys will know if you see this video.